My name is Gaganjot Kaur, and everyone calls me Gagan. And I'm here to present a session on real-time data platform infrastructure at scale. So before I get into this presentation, let me just give you a brief introduction about myself. I am currently working as a senior software engineer at Sony Interactive Entertainment or Sony PlayStation. I've been with this company for 6 years now. And from my work perspective, I was one of the early engineers of the personalization team. I'm a pure backend engineer, and I work on building services which are supporting the backend, and also I work on building data analytics platforms. So that's why my talk is today kind of focused on the real-time data analytics platform infrastructures, and I'll just go over the agenda. But before that, I've also put my LinkedIn here. I'll share my presentation with you all later so that you can connect with me and feel free to ask anything that you want to if we don't get time during the presentation. So moving on, the presentation agenda, I'll just quickly go over that. So I'll first talk about the real-time data. What exactly it is the real-time data and where do we see it? Then I'll definitely go over the high level overview of what a real time infrastructure design can look like when you want to build a scalable design. Then I'll also touch upon few technologies that we are very commonly using to build this kind of infrastructure and some real world examples around that. Finally, we'll talk about some of the challenges and then I'll summarize the talk. So let's get started. All right. So, what is real time data? But before that, I think I'll talk about connected experiences. So, when I say connected experiences, I'm talking about experiences which are connecting you with the rest of the world in real time. So, a very simple example, you are hungry and you want to order food today. You can take your phone, there is an app, you can basically create your order of what you want to eat in real time. This is a request. When you press OK or when you press pay, your request is sent to the restaurant. The restaurant processes your request, sees what you have ordered, and finally, accepts your request, bills your order. And once your order is ready, they notify a driver who takes this order and brings it to you right at your door. So this is an example of a connected experience. Other examples can be if you want to see something in right now on television, you can stream it. There are different platforms for that. So if you see, everything here is pretty quick, pretty real time, right? And today we have almost 25 billion devices which are online, and we need to connect them through this data, which is helping us to enable this connected experience. So in my first example of ordering food, uh, for example, they request that you put, oh, this is the food I want to order, this is the quantity I need. These are different data points which are being sent to the restaurant in real time. So overall, the data is being produced and consumed very continuously. And some of the other areas where this continuous data, which is basically the real-time data, is being used is to understand, what is your experience? Are you satisfied with this experience or not? Basically, to get a feedback mechanism. And overall, if I talk from a statistical perspective, connected experiences have created roughly $194 billion in last 5 years. So you can imagine how much data is being produced in real time today. So next, talking about the core components of the actual infrastructure behind the scene, which is doing this magic for you. So of course, there is a stream of data. So we need some streaming technologies that can handle this continuous stream of data being generated. There are some databases, for example, OLAP databases, online analytics processing databases, which can help us to store this data and then power some analytics dashboards in real time. There are some layers on which we publish this data, the publication layers. And of course, there are mechanisms we need to monitor everything. So, monitoring mechanisms. And going on a high level design from a design perspective, I'll just quickly go over this design and then we'll talk about each of these technologies individually. So, starting on the left side, you see a couple of devices like a laptop, a mobile phone, TV, gaming console. Basically, these are different devices that a user is on, and these are online devices. So they are generating a lot of data in real time. But this data, which is the stream of data which is being generated in real time, it has to be, you know, consumed in some way. So we have some publisher subscriber technologies. For example, here I've put Apache Kafka, a very commonly used technology for that, where we basically subscribe to all these different producers of data. So in Kafka's terminology, we call them producers of data. And we basically subscribe to these producers. We Once these producers give us some data, we publish it. And in Kafka's terminology, we are publishing it in different topics. So one topic can be related to the data for your real time metrics on what you viewed just now or what you clicked. One topic can be about data which is related to your recommendations that you are trying to see right now. So these are different examples. But once this data has made to Kafka topic, sometimes we need to do more processing on this. And sometimes we need to take this from Kafka and then put that into different data stores. So in that case, we can use some technologies to process this data. In this case, I've used a technology called Apache Flink, for example, which has very good capabilities to take this data and do some different types of processing, which can be aggregating this data over 1 hour, right? Or over a few minutes. And then you can put this data into different databases. In this case, I've put that data into an OLAP database. And these databases, in this example, the OLAP database can then be used to power real-time results. For example, showing you the recommendations in real time. So you switch on your TV today, you see streaming platforms giving you different recommendations of different shows. But all these recommendations, and even in PlayStation, if you switch on the PlayStation console and you see PlayStation Store, you have a lot of different recommendations. But the reality of those recommendations is that they can be very different from you for you versus your friend. But how do we know, what to serve you versus what to serve your friend? So in real time, we are processing a lot of different data points related to you. For example, what you played last time, or what your friends have been playing. And we are also processing the same data points for maybe your friend or for other people. And these data points make the list of recommendations totally different from for you versus your friend. So that's one example where we use this real time results. Now, understanding how well these recommendations are performing for you, whether you actually like this recommendation. So we have to kind of measure the metrics around that. For example, if you never click the recommendations I give you, it just shows me that the recommendations are useless, something is missing. So the clicks and views are some of the metrics that I can gather and power some real time analytics dashboards to see how well my recommendations are performing for you. Some other general examples can be fraud detection in real time, or even the ETAs that you see. For example, you order a taxi, you see the estimated time of arrival of your driver in real time today. So all these things are being powered by different online, mechanisms. Moving on, I'll just quickly go into a little bit detail of each of these technologies. So the very first technology I'm talking about is Apache Kafka. It's basically an event streaming technology, which is open source, distributed event streaming platform. When we think of building these kind of infrastructures at scale, Apache Kafka is one of the most commonly used technology by different companies. You can build very high performant data pipelines. You can build very highly scalable infrastructure using Apache Kafka, where basically the mechanism is what I explained earlier, where there are a bunch of producers that are producing data. You kind of subscribe to different consumers, the different topics as a consumer of this data. So these producers are producing data into topics, and as a consumer, I have different services that subscribe to this topic and consume this data, and then further they can do whatever they want to. But overall, it provides you great permanent storage of your data. It can scale very well and very high throughput. Next, I'll talk about Apache Flink. So I talked about processing of the data. And the Flink is one of the very commonly used framework, which is used for performing computations on bounded and unbounded data streams. So when I say bounded and unbounded, I mean to say there are some data streams, they have a start point, but they don't have end. The data is continuously coming in. So when you switch on, for example, a console, there are millions of people switching on the console and watching the content. This data is being continuously produced. But those are unbounded data streams. But there can also be data streams which have an end. So this is the start of the data set and this is the end of the data set. So for both of these data streams, Apache Flink is a great platform to perform different computations. For example, sometimes you want to aggregate data of a user over 1 hour. For example, you want to know um, what did Gagan view over last 1 hour, right? Or you want to see how many clicks and views you got on a particular recommendation over last 1 hour. So these are the kind of computations which are very complicated when you perform them on real-time data, which is continuously coming. So Apache Flink provides very good inbuilt functions, APIs to, you know, basically enable you to do these computations. So you don't have to write things from scratch. There are some inbuilt features they provide out of the box, and it's very high performant, high in terms of uh, the correctness guarantee, which means that it guarantees that your results will be correct. So there are different mechanisms in Flink, like checkpointing, save pointing, which can ensure that even if your pipeline fails, you can recover the pipeline from the point where it failed. So that's a very high level overview of Flink, of course, but there's a lot more to it. Moving on, I'll talk a little bit about the OLAP databases, the online analytical processing databases, which are basically used to analyze business data from different points of view. So here I've put some technologies like Apache Druid or AWS TimeStream, but there's a lot more examples of these databases. So these are some time series databases where you can store the data based on the timestamp at which it gets generated. And then once this data makes its way into, say, Druid or TimeStream, you can then use this data, build some APIs on top of it, which can power your real-time, business dashboards, or it can power some other things like providing some real-time metrics or providing some real-time results based on those metrics eventually. Moving on, I'll quickly, yeah, give you an example of what this infrastructure can look like. So I have some Kafka producers here, like a recommendation generation service or an advertisement server, or some metadata related to the products which are offered, say, on a platform like PlayStation. So these are different producers of data. The data they produce makes it to Kafka. And then if I want to perform some processing on top of this data, I can use Flink data pipeline on top of this Kafka data. So in this case, that Kafka topic where the data is being generated becomes a Flink source. And eventually Flink can process it and put it into different databases like S3 buckets, TimeStream, or Aerospike, or whatever is the use case. But the destination where we put this data in Flink's terminology is called as Flink Sync. And eventually, these data stores can power different cases, like you can use this data to train your machine learning models, or to power some features on your mobile apps, or to provide real time analytics dashboards. Talking about the challenges, of course, this kind of infrastructure comes with a lot of challenges, like the quality of data has to be very good. And when you process so much of data, there's a lot of cost involved. So playing around with the configurations and making sure that you have a good management of cost and the real use cases is very important. Also ensuring low latency and scalability of this infrastructure. So you have to do very good performance testing. You have to have good monitoring and alerting mechanisms for this data. So these are some of the challenges that you'll come across on a high level. So, summarizing this whole talk, basically, you can see that real time data platforms have a lot of potential to power your connected experiences. And we are using a lot of different technologies behind the scenes to do that, which can be databases, analytics engines, even machine learning, if we go further, in depth into this. But all these technologies are helping us to process and publish this data for the consumers. And with that, I would say this is the end of my presentation, and I would love to take any questions from your side. But thanks a lot.